Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at some of those math topics that we all know and love, but maybe look at them through a different lens of statistics. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight we're joined by our two panelists, Diane Broberg and Karl-Heinz Haas. Diane has been around for a little while, taught math for over 30 years. She's served on writing teams for TI and taught many summer workshops. Making math come alive for teachers and students is what keeps her creative. Outside of math, she loves running and baking. So Diane, it's great to have you with us tonight.
Thank you. It's good to be here.
And Karl-Heinz is a graduate of the University of Heidelberg with master's degrees in physics and science education. He's taught science and math in Germany as well as New Jersey for nearly 10 years, and then worked as an administrator in several school district roles ranging from math science supervisors all the way up to assistant superintendent. Then he moved to Florida, where now he's at the Pine School in Hobe Sound, Florida. He's presented workshops at conferences and other PD programs around the nation, and he's especially proud of adding a newly designed STEM Lab course to the Pine School's program that integrates many of the TI STEM lessons and Innovator Hub and Rover activities. And so I'm really excited to have Karl-Heinz hopefully here with us tonight. He was just here a minute ago and had some technical difficulties. So we're hoping he joins us again, but also want to include that he also is going to be retiring at the end of the school year. So congratulations to Karl-Heinz as well. So Diane, would you mind talking through our agenda for tonight?
Sure. Our goal tonight is to work through a little bit of middle grades and algebra connections with statistics. We've put together some activities that have to do with percents, proportions, linear inequations, and exponential decay. We're going to play with the activities both on the TI-84 CE and on the Nspire. You're going to see a little bit with some M&Ms, and one that Karl-Heinz put together very nicely for this. It has to do with alligator math. And at the end, I understand there gets to be a webinar drawing.
Yep, we are going to be giving away to one lucky winner a TI graphing calculator of their choice. All right, so I'm going to be working here to get Karl online, but in the meantime, just a couple things will be.
I'll talk about the expected outcomes if you like.
Sure, that'd be great.
Sure. So we're hoping at the end of this whole thing that when you sit and think about topics that are really hard to get into the curriculum, and I know those are a bunch of the statistics topics, that you can figure out how we can treat traditional topics through a statistical lens. Our second hope is that you're going to leave being able to connect middle school math and algebra topics to data. And the final is that you can use technology to help students build the concepts and help make connections.
Thanks so much. And I love that we're doing this because, we were talking about this as we were kind of doing some prep for the webinar that, if I open my Algebra 1 textbook, there's a section on probability and statistics, but it's usually at the end. And, it's like we never can find the right place to put that. And I think what we're trying to do tonight, or I should say not we, what Diane and Karl-Heinz are trying to do tonight is really integrate that into your math content already. So we'll be using the chat window tonight to send our own messages. And if you have any questions for Diane or Karl, use that Q&A window on the right side of your screen. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. All right, Diane, let me give you control, and I'm going to mute myself and try and work to get Karl back on.
Okay, thanks, Michael. So let me share my screen with you. Mike, I've lost the ability. Oh, wait, here it comes. Here. So Karl-Heinz is dealing with a storm down in Florida. So he told us a few minutes ago that he was dealing with some storms. And so we're going to kind of play with this, and I hope you'll be kind of patient with us. So that's not all I would like to look. Hold on just a second. Let me get it so you can see the whole thing. Okay, so Carl Hines and I have been playing this and spending some time thinking about um, statistics. Both he and I teach statistics. I teach AP statistics. I'm also the chair of the math department at the school that I work at. And I'm the chair of the math department from JK to 12. And so as he and I were talking, we're like, how can we begin to get teachers more involved with statistics and do a little bit more statistics in the class? We see it as a growing topic that students need some attention with, and it becomes an SAT and a topic that they can learn from. So we began to talk about these topics. At the same time, my middle school teachers were talking about the same thing. And we were having this conversation of how can we get more statistics in our curriculum? And my teachers kept saying, Diane, we can't do this. It's too hard. We have all these other topics you want us to teach. How can we do statistics too? So one of the first activities we decided to put in is we were talking about, okay, how can we teach ratios, portions, comparisons, converting between fractions, decimals, and percents. And I said, hey, we can do this through a statistical lens. Let's try to do something. Let's try to do some things with some box plots, some dot plots. Let's look at this 5-number summary and see how we can do this. So our 7th grade teachers in the fall decided they would do that. They started with a review, did some stuff with our percents and ratios, and began looking at the information. I said, we'll try this as an activity. How about we get M&Ms and we'll give every group of kids a group of M&Ms. We'll give them a bag of M&Ms. They can count them. We can, from the data, we can then create some box plots. And they're like, first of all, Diane, we can't have M&Ms in the middle school. We can do something else. So we decided to do Smarties. But so the data we're going to work on today, though, is data that I collected through a workshop. And so what we did is we gave every single person in the workshop a bag of M&Ms. Their job was to take and sort them with color. And what we wanted each person to do and what the data we collected was all of the data for each different color. I chose one color today. I was in a red mood when I chose it. And so I got my data. I first started on my whiteboard. And this, interestingly enough, is what I actually do with statistics also. My AP statistics students also start with a dot plot and putting the information on the board. So we looked at the number of red M&Ms. We graphed it as a box plot, first as a dot plot, and then we began to talk about it. Now, in middle school grades, we want to think about, okay, what does a box plot actually do? Well, we know box plot does quartiles, so we do 25% each time. So how do we take a graph that is a dot plot and how do we make it into a box plot? And this is one of the activities that we did when we were working with them in the middle school. And they took the data and move it from one thing to the next. So I'm going to try now to do with you. This is me doing 2 technologies all at the same time. This is where Carla Hines and I were going to work together with us. So I am going to do it now. We're going to do it with a couple different things. The question then is how do we does technology need to come into this? It can, it doesn't have to. I do really like it with both the Inspire and the 84. And at school, we use both. We have used the 84 in the past. We're working towards using the Inspire a little bit more. I'm going to try to do it with you first here with the Inspire. So here is the data that we have. So this is the that we created. We just did the red ones. I actually did have the data for all the other colors. You can also do it with the total number of M&Ms. So the first thing I kind of asked Carl Hines to do is I said, okay, Carl Hines, can you make this into a box plot? So he really nicely made it into a box plot for me. But then my next question for him was, well, Carl Hines, I really would like to actually make it into a dot plot. And she said, so, well, Diane, I can do that for you. So he did it. So let's see, he started and he added a page for me. And he added a data and statistics page. And she says, okay, Diane, you want a dot plot. We come down here to the bottom, we click to enter, and he put the red ones in here. And so here they are. And so what do we want students to be able to do? Well, in middle school, we'd like them to look and we'd like them to connect, put the dot plot and the box plot together. So Carl Hines said, man, I can do that, Diane. So he took and he hit control, and I think it's 4 here. And he said oops, I got the wrong one here. Let me undo. Let's control Z here. I want my other one here. It looks like I got this one here. Control. And there I have the two of them next to each other, but I'd really like to look at them over top of each other. So what if I change my layout here? So if I click menu, let's see here. If I click dot and I click my page layout, I can select my layout here, and I would like them to be horizontal. And now it's an interesting graph to look at. I think it's an interesting thing for students to realize that 25% of my data up here is 25% of my data down here. And when we do that with middle school students, they can count. And to look at the two graphs side by side is actually, I think, a very helpful thing for students to do to understand the relationship. I will tell you from the standpoint of an AP statistics teacher, I think the other good thing about it, it allows students to see the relationship between the shape of a box plot and the shape of a dot plot. And those two things together are things that are kind of important. We did one last thing with this. If I go back to my original data, we actually had the red here. So there's another comparison we were interested in looking at. So this person had 11, the first person had 11 red and 55 total, where our third person had 11 red and 52 total. So are we correct in saying, well, these 4 of the first 5 people had 11 red M&Ms, but did they have the quote same number of red M&Ms, or did they have the same proportion of them? And allowing students to see this relationship. So over in our third column, we actually approximated it. We approximated it by taking the red and dividing it by the total. We got a list of, we did it approximately so that we would get the decimals instead of getting the fractions. And if you'll notice over here on the third page, we graphed it using proportions. What should students recognize? Are these two graphs identical? I hope your answer to that is no, they're not identical. And that students can begin to understand that counts are not the same as the proportion. I think that's a way we have misleading statistics at times, and we allow that just the counts or just the proportions to be the driving factor where in actuality there's a nice relationship between the two. So that's activity number 1. It's a different way of introducing a statistical topic through your traditional topic through your statistical lens. It's connecting proportions, it's connecting percentages, and it's connecting box plots in a fairly practical way for students to look at it. My middle school teacher said that the activity was a great success, that it allowed students to see a practical of why we do some of the stuff we do with percents, how we use those to build a box plot, and it began to make it the beginning of a relationship for them. Okay, hey, look, I think you guys can't see this, but I think that Carl Hines may have just joined us. I think we should all clap. You can all say, woohoo, good job. The question real quickly is, what can we do with the 84 with this? So let me do one last thing with the 84. So if I go back to the 84, 84 doesn't have the same capabilities here completely. So the first thing I'm going to do on the 84, I do have the exact same data. Later in this webinar, I'm going to show you how to get data on your calculator a little bit more effectively. But I'm going to do this on the 84 with a stat plot. I'm going to turn it on. So I go to second y equals to get my stat plot. I am going to turn it on, and I am going to create a box plot. So there are 2 different box plots. I am a strong proponent for this. For the middle school, I would use this one. This one, the one to the left, is a modified box plot, which means it identifies outliers. I don't think that's a topic I want to do right now with my 7th graders. I just want them to see the 25%. So there we have now my list. My list, I actually imported the data using the M&Ms. So I'm going to hit second in list to find my data. If I scroll down here, there's my M&Ms data. I'm going to hit enter. It is there. I have a frequency of 1. I changed my color earlier, so it would be red to match the M&Ms. I'm going to hit zoom, and number 9 for stat. This will give me my best window possible. And there it is. There is the data in a box plot. I have a little bit different with tracing. If I click trace, I can see my median. I cannot put a dot plot on the 84. So that is one distinct difference between the Nspire and the 84 when it comes to this type of graphing. Okay, Mike, do you see any questions or comments in the chat that we can address?
I just saw just a question from Michelle. Michelle said, with only 15 Smarties in a role, do you typically give students 3 or 4 roles? Like, how many roles do you think they need to be able to do this well, if you're going to use Smarties?
Yep, when we did Smarties, we actually gave each, I bought an enormous 5-pound bag of them, and we gave each student 3 packages of Smarties. Okay, so I'm going to stay here for a minute, and I'm going to pass you over to Carl Hines in just a minute. So our next activity that we want to kind of look at is, I'm going to start here, is we talk about a second activity and a second thing. And another big topic that we do always, we do it in middle school, we do it in Algebra 1, is looking at things like rate of change, y-intercepts, interpretations of slope, interpretations of the rate of change, like how do we put them in context, and evaluating functions at a point. So we thought about those as traditional topics and thought, okay, well, what are statistical topics that go with them? And lines of best fit, linear regression, interpolation, and extrapolation are the activities that are statistically speaking. And so what our goal is to take those traditional topics and treat them through this lens of data and statistics. Okay, so I think with that, I am going to, whoops, I got to escape here. I'm going to, we're going to try to do this first on the Nspire. So I'm going to switch my screen over to Carl Hines, and he is going to show you, he's going to walk us through.
And I'm going to start by apologizing. Although it is not hurricane season yet, we are having horrible weather right now. It's gusting up to 40 miles an hour or more. And so I'm having some very bad internet connectivity problems. Hopefully not anymore. Hopefully we're going to make it through the remainder of the webinar. So thank you for making this happen, Diane and Michael, and thank you for being patient. So let me move on. Speaking of Florida and speaking of Florida weather, what about a more Florida related activity? I'm going to switch over and share my Nspire screen with you. And there's a question. Even if you're not from Florida, if you're from one of the southeastern states, you may face the same question. How do you measure alligators? Because most of the time you can't really see very much. And there's one of the slides we have in our PowerPoint is asking that question, well, how do you measure an alligator? And there's a rule of thumb that Florida Wildlife and other organizations will tell you. Moving to the second. This is what you can usually see when you see an alligator in the wild. Actually, if you're lucky enough to see anything. The rule of thumb is the distance between point A, between the eyes and the nostrils of the alligator, measured in inches, or as they say, estimated in inches. They do not encourage you to hop in the water and actually measure that. But the rule of thumb is that distance in inches is approximately equal to the length of the alligator in feet. So on this scale, for the little picture, that would mean that's an alligator that's approximately 12 feet in length. So what we did is we put the total length of the alligator and we put the head length. And again, I should explain that. Interestingly enough, when they capture alligators, dead or alive, they actually do measure the entire length of the head. That's pretty much the only time they can do that. So any records of alligators captured and relocated or captured and moved to happier hunting grounds, they usually give you the length of the head and the total length. So we wanted to plot that and see if there's anything to that relationship that they tell you about the length of the distance between nostrils and eye and the length of the alligator. So we plotted that. We actually got a very nice relationship there. And one of the first questions I would like to ask the audience, and if you could just reply in the chat, and Michael, maybe you can share, what are your thoughts on why we have data in these two very distinct clusters? So any guesses are welcome. Any responses you may have in the chat, go right ahead. Michael, are you?
I was going to say Michelle put gender. Norma said maybe very young and very old alligators. I think gender from George, males and females.
Interesting. So we do have two camps here. It seems we have the younger and older, and we have the male female. And in this case, the male versus female have it. So the upper cluster, the head length at 22, 23, 24 inches and more, those are male alligators that were recorded, and the bottom cluster are female alligators. But certainly the age guess is very valid. So if you look at the graph now, we ran an analysis, we ran a linear analysis here, and it does seem to lend itself certainly to linear analysis. And we got this graph, and as you can see, the slope of this graph is not quite what we would have expected. If it were a one-on-one relationship, a one-to-one relationship between the length of the head and the total length of the alligator, we should have a different slope there, right? For every inch it goes up, it should go up 12 inches in body length. We only have about 7 inches. Without wanting to get into a guessing game why that may be, if you remember during the intro, I said any alligators that are actually measured when they're captured, relocated, or whatever, they measure the head length. When you're going back, when you're estimating, if you see one in the wild, you typically do not see the entire head of the alligator. You only see this distance between nostrils and the eyes. So that's where that recommended estimate is coming from. But the true relationship that Florida Wildlife and others, Louisiana, Mississippi, are giving us is really head length versus the total length. And you see from those data points that we have, that's a very nice relationship there. Wanted to share with you another relationship here. Also took a data list that is available on the internet, and we posted a copy of one of them anyway in our shared folder. And we put the length of the alligators and we put the weight of the alligators. And again, we actually started out with, or I started out with 2 clusters here. We have the length, the weight, and we have the total, all of the alligators that I had access to for the data. And we plotted them again. And moving to that screen, it looks very close to the previous linear plot, which you would kind of expect that the longer the alligator, the heavier the alligator. The longer the head, the longer the alligator, the heavier the alligator. And we have a very nice match between the two data representations. Again, for if I read the slope correctly here, for every inch in length, this is the length of the alligators that are represented here in inches. For every inch, the alligator is about 11.4 pounds heavier.
And Karl-Heinz, I have a question. There's a good question in the chat. It says, how do you get this data? And then how do you know which math relates best to the data? So I know when you and I started, we decided we were going to try to do something with alligators. I don't know how we chose alligators, but it was a conversation I remember you and I had. But now, how did you find this data?
I mean, I did some research. I went to Florida Wildlife to start with. Florida Wildlife Commission is a rich source of data for alligators captured, relocated, etc. in Florida. And of course, the data is then mostly those for those alligators that were captured, that had to be captured, that had to be relocated, or were found dead for one reason or the other. So the database is kind of limited, which also explains why we have these two clusters. So they're not going out there and they're measuring every available alligator that they can find in the swamps. That's a very kind of a select number of alligators. And so the interesting point that we're trying to make with this data representation is, of course, that there is a very nice linear relationship that is showing up here, both for the head length of the alligator and its length, and then the length and the weight of the alligator. One last little interesting point. I don't know if anybody was paying attention at that moment. When I scrolled a little bit too far, I had actually taken two of them out because they were really messing with the data, and who wants that? But the point is, the state record alligator for Florida actually was only 166.5 inches long, but weighed 1,043 pounds. So I almost called him short and chubby, but I think at 166, that's still long and chubby. But other than those two that were kind of off the chart, there's a very nice linear relationship that you can explore with your students. Other states have similar data. You can go to Louisiana, you can get information about alligators that are captured through the various programs. So it's a different source of information. It's an interesting source to explore a little bit more with students to kind of scroll back to the picture to just say, hey, this is what they're recommending you do. If you see one and you're not too close, try to estimate how long it is by just looking at this distance that you can always see if the head is coming out of the water. So that's kind of a starting point of the discussion there. So Diane, I think you wanted to share a little bit something about data import there.
Yeah. So I do like the other statement in the chat is that there isn't any data from 105 to 150 that no alligators measure those in inches. It is interesting. It is a conversation I would actually have in a middle school class or with a high school class about the data is really bimodal. And the bimodal, or it is actually, we can look at, if we look at it as a whole, we have categorical data that is piled on top of quantitative data. And that's kind of an interesting thing, and it provides some interesting conversations. And so in my AP stats class, I probably would have separated it and looked at the two things together and look at those two different groups and see what happens. And then if we put it all together, kind of what Karl Heinz did at the end, he merged the two lists, and in merging the two lists, look at it as a whole and see, is there difference in relationships? What an incredible thing to do with middle school students, to look at it in those three lights, for them to see technically three different, potentially three lines. You could see the line for the female alligators, the lines for the male alligators, and the line for the alligators put together. And I would wonder, it's a question that I would explore with them, is the data parallel? Is it exactly the same line? Really interesting questions that with technology are really interesting and are easy to investigate. But let's see. So Karl Heinz, you're going to switch it over so I can show them something with the
yeah, let me
84. So
stop sharing.
So one of the things that I've done a couple workshops recently, and one of the participants said to me, Diane, I really would like to do this, but the dilemma is I don't have any, I don't know how to get this data to my calculator. And so I realized that was actually some of the issues I had. Is for a long time, I didn't know what to do. So there is a piece of software. It is called TI-Connect. And TI-Connect is a really, really, really good piece of software. And it allows us to get data. So what I had done is there is in TI-Connect, there's a variety of different things we can do. If I go up here to actions and I look at this third thing, it says import data. And it says it has to be a CSV file to lists and matrices. So what I did is I took the data that Carl Heinz sent me. He sent it to me as an Excel file. I saved it. I changed it from an Excel file to a CSV file, which is very easy to do. When you go to save as, you just need to save it as a CSV file. And so when I click on import data, now I did make it so it came up here quite quickly, but wherever I have it saved, I click on this little alligator. I would like to open it. And now it tells me, it says now, it gives me a few pieces of information here. Prior to importing, make sure you've done this. You can only have numerical values and you cannot contain any text. Now that's not true with the Nspire. With the Nspire, it's much easier to bring data in. It's just a copy and paste. But so what I had to say to this is I knew I had two lists of data because the only two that I brought in the head length and I'm going to bring in the length of the whole alligator. I click continue. Now I can name them anything I like. I can call them list L1 and L2, or if I click on this, I can custom and give them any name I'd like them to have. So we will call the first one, I know I've got it, we'll call it HEA. We'll call it head one because I have another one in here, and I'm going to click done here. And then it says, what would I like my second one to be? And I'll do custom here. And I'll do LENG for length. I'll put a 1 after it so that they match. I click done here. It says, am I doing all this? I say yes, go for it. And I click send. And it just did it. And I'm fascinated by it because I'm like, yes, my data is there and I did not have to type it in. So let's look at this a little bit from the 84 standpoint. So I'm now going to share my 84 with you. And we just talked that I have put the data in here. So this is my emulator for the calculator. I am going to click second in stat plot. And I'm going to turn off the first one I did. And I am going to turn on a second one. So if we come down here to number 2, I would like it to be a scatter plot. So I'm going to use that first thing. I did a little of this. I set this up a little bit earlier, but can I just show you how to do this? The question is, where do I find that list head? Most of the time it's L1 and L2. But if you're here and you click second and your list, you have all of the names. Anything you've named a list, it'll be there. So you'll notice there's a variety of ones here. So I used the one before, like I told you, I used one for head. And I used the second one for alligator was my Y, I did the same thing. Okay, and my last step always, so I've got my setup, I can use whatever mark I'd like to and choose the color. I chose red again, I don't know why. And then my next part here is I'm going to hit zoom. And I explained to students that zoom 9 will take the data that I've given it, whatever's in those two lists, and it will give me my best window possible. So if I hit number 9, oh no, what did I do?
Check the second list you.
Did I not turn it off? Second list here. Oh, I thought I turned this off. I've got to turn this one off. This is what I did earlier too. So let's go back again. I'm going to hit zoom at number 9.
Check the list you selected for your plot too.
Really? Second stat plot.
I remember didn't you import it as length?
Yeah, I did it. Well, this might be in my ones from earlier. Let's see what these two lists look like. I'm not sure why it's not liking my list right now. So let's see what I can do for a second. So I'm going to show you this. Let me go to stat for a second. Let me go to edit. Let me see what these lists look like. So if I go up here to the top, we'll see what the issue is. And if I hit second in list, let's see what number 8 looks like. This is my head data. That looks like what it's supposed to look like. Let's go over up here to the top and let me do the same thing to see what it looks like. Second in list. And this is the alligator. I think that's what, and let me look and see if I know and have the same list size. So let's see if I scroll down here. It said it didn't like them. Whoops, sorry, got too excited. They're the same size, so let's try again. Now they're in list L1 and L2.
Yeah.
So you know what? I'm gonna. Oh, look, and here's the problem. It's listed, and I had somehow had L3 turned on. So let's do this. I'll turn number 3, and I will turn that one off. Let's go back. And my second one's on. Now we should have great success. Zoom in number 9. There it is.
There you go.
So what do we want to be able to do? Again, we want this concept of a line of best fit. Now I'm going to show you 2 things. The first thing there, if we go from to stat again and over to calculate, we can do linear regression, which is number 4. But I think sometimes when we do linear regression, we let the calculator do all the work. But there's this other really cool function on the 84 that I think is sometimes so underused because it's way down at the bottom. So if you keep going down to letter D, you get manual fit. And if you hit enter now, it says, where do I want to store it? So I want to store it in Y1. To get that, I'm going to hit alpha and F4, and I'm going to get Y1. So that's where it's going to store it. And I go down here to calculate. Now, what it says I need to do down here, it says drop some points. So I like students to think about, like, where should this point go? So if I have a line of best fit, I am going to use my cursor to get to somewhere where I think the line is about. I can use a point if I'd like. I can use an exact point, or I can put it somewhere in the middle. I'm going to choose there. Why? Because it looks good. And then I'm going to, that's my first point. Now I'm going to go over. I'm going to go up. And I'm going to, as students are thinking about this, my question for them is going to be, okay, let's talk about what are things lines of best fit should have. Well, we know that they should go through a lot of points. We know we want the same number above and the same number below. When you get it to where the student thinks it should go, they need to hit enter. So I've dropped 2 points. I'm going to click enter. There is my line. Now, some students are going to say, I just did a great job. My line is done. And they can do that and they can hit done. Or notice what it says up top here. It says, if I really don't like my line, I can change it. By like right now, my slope is highlighted. So let's say I think my slope should be a little bit less. I think my slope should be 7. So if I hit enter right now, it'll come down here at the bottom. Maybe I think it should be just, and I should delete the rest of this stuff. Okay. And if I do that and now hit enter, it changed my line. I was like, ooh, my line was much better before. Or maybe I think the slope is correct, but what I think is wrong this time is I think the y-intercept needs to be higher. So I'm going to go over here and I'm going to change it like every good middle school student does and be like, well, it needs to be a whole number. So it needs to be 3. And I'm going to hit enter. And there may be what I think my line should be. Whenever I think my line is what it is, I take and I can click done. To click done, it's one of these soft keys. The Y equals over to the graph, and I hit graph. And that is the line of best fit. And so usually, I love the manual fit. And the reason I like it because it allows students to interact. Usually the next thing we have a conversation about is the concept of what is linear regression. Let's see, how well did I do? So linear regression, which is number 4. I know my X list. We've talked about that. My X list hit second in list. My X list is number 8. My Y list is second list again. It is alligator. And my frequency list, I have none. So my frequency list is deleted. And I'm going to store the regression this time. I'll put it in Y2. Oops, didn't get it. Sorry. Second. Oops, I got it. Wait. Gotta go back. Sorry. Apologize there. Let's try it again. Second, calculate. Number 4. Got those 2. Need to store it. Like to store it in Y2. That'd be alpha. And calculate Y2. Really like that. Calculate. There it is. Let's see. How well did we do? How well did we as a student do? Oh my. They're very different, aren't they? Ooh, I wonder why. It's an interesting question. So what I wanted you to see in this, for those 84 users, I really wanted you to see that manual fit. Manual fit, again, you get it by hitting stat, over to calculate, down to the bottom. And here's your homework assignment, all of you 84 users. You need to try the letter E later. Letter E is really, really, really cool. You'll like it. Try it on your own, see what it does, play with it a little bit. That's your homework assignment. Okay. So Carl Hines.
I had one question in the chat. I think it was Robert who asked the question. What is the limitation, or what are the limitations for the list? How many values can I have in one column? Do you know the values in terms of the size of the list that I can import?
I think we can import 1,000. I know we can import 1,000 on the Inspire, and I'm almost 100% sure it's 1,000 on the 84 also. The Inspire it's much easier to import on. The Inspire is literally a cut and paste. If you have a set of data that you have put in any Excel file, you can do it as you copy, you paste, you go to cell number 1 in your list and spreadsheet for the Inspire, and it's all there. It works so nicely. I can do my activity on Sunday night and have it ready for Monday morning real quickly. But I think it's 1,000 pieces of data.
And I believe on the Inspire, it's even higher than that. But that kind of ties in with another question I saw, and that was answered, at least for those who followed the chat. Somebody had asked, why would you not just type it in? And I think the answer that was given in the chat is also an answer for the general audience. If you have a list with as few values as ours had, you could probably just as easily type it into and set up your lists on the 84. It's really just an advantage if your lists have many more values than the 20 or so that we had in our list. That was more demonstration. So yes, it is certainly an advantage to be able to import it from a CSV file directly from the Inspire to an Excel file or Google Sheet, then into CSV and right into the 84. So that's how Diane and I shared our data back and forth.
Yeah, can I answer a real quick question about TI Connect? What TI Connect does, its general purpose is to connect the calculator and the software and the computer. Notice this right here, what you see there is actually my calculator. If I double click on my calculator here, that's what's on my calculator. So if I want to delete things, if I want to add things, I can do all of that through this. So it allows me to, I don't need the emulator. This is my calculator that's in my hand right here. So when I want my students to have data, I can take it from my computer. I can take it from that list I just created. I can go completely and not use the emulator. I can just use my 84 because my 84 connects completely to this TI Connect. So I don't need an emulator. I just need a calculator and a TI Connect. So that's what it does. It allows me to save things. It allows me to copy my applications, programs, all that type of stuff. It allows me another place to save it. And that's why I've started using the TI Connect as much as I have. Okay. Other questions before we move on?
Michael, did you see anything else?
I think the only question that I actually don't know the answer to is from Robert. Do you know if we can use a thumb drive to import the data? So I'm guessing, right, if you have a thumb drive with the data on it, would that be okay as well to move that over as a list?
You need the TI Connect software. The only way you can get this is for the 84. The only way to get data from your computer, like from a list of an Excel spreadsheet, anything like that, onto the 84, because can I show you one thing real quickly? Am I going to have it easily defined? Ooh, this is a really good question.
I mean, the data, if maybe I'm misunderstanding Robert's question, the data could be on a thumb drive. And when you're looking for it to import it as a CSV file, you would just import it from that thumb drive. The file doesn't have to be on your computer, but you need to bring it into the TI Connect software, or if you have the Inspire, you can have the file on a thumb drive. You would just open it up and copy and paste it into the Inspire list and spreadsheet application.
I agree. Okay, Karl Heinz, I'm going to drag this over to you.
Bring it on.
We have one last activity that we are going to look at. And this last activity, I really appreciate it because this is Karl Heinz again at his, he went and bought some different M&Ms this time. He's got to show you the picture of them. I think that's my favorite part, Karl Heinz.
Yeah, we are allowed to have M&Ms actually. We're not allowed to have M&Ms with peanuts in them. So my activity was limited to milk chocolate M&Ms, and pre-Easter, the holidays, we had all these fancy colors. So I chose this particular bag. So the first thing we wanted to share with you is actually a pretty nice and straightforward activity. Yes, believe it or not, this was a bag of 320 M&Ms.
So
that survived exactly half a day in my classroom, and then it was gone after the activity was done. In this particular type of M&Ms, we had the green, purple, and brown, and 320. So we had 190 green, purple 70, and brown 60. So one of the first things we wanted to share with you, a nice feature on the Inspire, is of course, how can I make a pie chart or a dot plot or anything if I just have totals? I don't want to just plot these three numbers. So if Diane, you want to kind of talk us through this?
Yeah, cool way to do this. So Karl Heinz put his cursor in expanded counts. That's what he's called it. Now, if you hit equals.
Hit equals, okay.
Yeah, and then you need to go to, if you click your little book.
Right here.
That book is a catalog. And so notice up along the top for the first one is literally like a catalog. It's got everything in it. The second one has the symbols in it. The third has got conversions in it. But we're going to use, we're going to use the book. And so if you use a letter, it will automatically get you to the right spot. We want this frequency table, which is what we had, and we want to make it into a list. So if we click, now notice two things. Notice at the bottom that he had his wizards on, and the wizards on told us exactly what he needed to put. So the first thing he needs to do is he needs to choose what is his variable. So that's color in this case. So you can get that from clicking, either type the word color or hit your variables key, put a comma, and then we need to do count number 1. So the way to get that is either he can type it, or on the handheld, you can use the variables key and get it that way. So
and you also notice that when I stopped typing at count, the fonts were not bold. As long as I don't have the correct column name in the parentheses there, it will not turn bold. And I kind of know that's kind of a check that I either mistyped something or I didn't type the complete name of the variable in there. So as soon as I say count 1, it now knows I want to use this as my count for the frequency list.
Yeah. So, hit enter, and they're going to see what happens. It's so cool. If Karl Heinz, scroll down, show them that it doesn't. What it just did is it put the word green in there 190 times. And then it put the word purple in there, 60 times. And now, hey, can you graph it?
I can. So if I could stop fast enough, you would see that I actually have 320 values in there right now. right there, 320. You would like me to graph that now?
I would. Let's first try. Look at that. That's for everyone.
It's a little bit confusing there. I have, how many data points do I have there? Probably 320. So what variable do we want to have on the bottom? Want to have the color?
I think, oh, if you do color, you just get them each one time, don't you?
Oh no, then I only get one, right? So
I think it's was it expanded count?
Expanded count 1. And there are my data point.
Ah, that's a cool looking graph. Now, sometimes though in middle school, we also want to talk about pie charts. And this one become a pie chart?
Let me see if I can, where would I find that? On the menu? I have my plot types. Oh yeah, look at that. Plot types. I have a pie chart.
Now, what's every student going to want to do? Look at the colors. So we won't do it now, but Karl-Heinz could change. You notice it says purple, but it's green. And you know what every student wants to do. There's your fill color. Find your close enough to purple.
And are we going to call magenta purple now?
Sure. As long as we can call the green, yep.
That's the brown.
And while this seems to be trivial, I think it's really important that we actually encourage students that the importance of that our graphs actually do match, because I think one of the challenges I find with students in class is that their graphs don't match, that they don't always label. So slightly trivial, but also really kind of cool. So let's see, Karl-Heinz, what else could we do with that data? What did you do with all those M&Ms that's different than just...
Well, I went back to the very first slide actually to show that page. If you look closely, you can see that some of the M&Ms have the letter M facing up, and some of them either don't have a letter M on them or it must be facing down. Well, of course, I'm sure everybody knows that all the M&Ms have the letter M on them. And just when I tossed them all out on that paper, some of them landed with the M up and some of them landed with the M down. So we're thinking one neat activity could be I wonder what would happen, how many of them, if you just randomly toss them out over that large piece of paper, how many of them land right side up or letter up and letter down. So jumping forward, now that you saw what it looked like, originally, so trial 0, before anything, we knew we had 320 M&Ms. After tossing them once, the first trial, 142 were left with letters facing up. Then we did it again, and the next trial, 85 were left, 85. Another trial, 42 were with the letter M up. And scrolling down 5, 6, and after 6 times, 6 repetitions, we were down to 8 out of the 15 that were left behind that were now facing with the letter M up. Why this activity? Why are we tossing 320 M&Ms and counting how many of them are landed with the letter M up and how many with the letter M down? Well, let's plot this information. What I wanted to see was, what if we plotted the number of the trial, the number of how many times we tossed it versus the number of M&Ms with the letter facing up. And this is what we saw. Now, do I see any wows in the chat? Michael, is there any? So
I think it's a pretty wow. And I think it's been really nicely to one of those questions that I know every middle school teacher has to teach. We have to teach students that there's a difference, that all data is not linear. And so how do we get this relationship? How do we get them to see data that's nonlinear? So this is an example of a set of data that is not linear.
And it's just a very crude representation of half-life. So basically what we're doing with this activity, very often in the algebra classes, we use exponential decay, half-life of radioactive materials as an example, where after a certain amount of time, half the material is left over. Yeah, I saw in the chat chemistry, absolutely. So after half, whatever the half-life of this is, after one cycle, after half the life, about half, another half, another half, another half. And of course, we have real data. We don't have a perfect fit. Chemistry would tell us that after one half the lifetime of radioactive material, not exactly one half of all the atoms are left over. That is also a model that real data would show is not exactly one half, one half, one half. But we looked at ways to analyze this data now. And similar to what, so if you've introduced exponential decay already or exponential functions, you could do the same thing that Diane introduced for the 84 with a linear function. We could plot function, have the students try and come up with a function to model it. But in the interest of time, and since the students will see that anyway, regression is right underneath that. And I'm wondering, is that an exponential decline? And wouldn't you know it, it is a very, very nice fit of our real data, M&Ms tossed all over the table, simulating half-life. Those of you who are statistically inclined and understand what the R-squared value here is supposed to tell us, it's that 99% of the variability are explained by this line that we have, that is exponential function. So very nice application of real data for mathematical modeling for the algebra classroom through a statistical lens. And Diane, I'm going to stop sharing there. I'll pass it on back to you.
I think you need to pass it on.
Sharing.
I think you need to pass it to Michael.
I'll pass it to Michael.
Yeah.
I will do that. And Michael, if there were any other last minute questions, and then I'll let you, we'll close it out.
Just taking a peek now.
We have to tell it. One question I saw here: the Inspire? We have to tell that we're doing regression. We have to tell it that we'd like it to be exponential regression, just like on the. If we were doing that same exact activity on the 84, we'd have to tell the 84 that it's exponential regression. Because good or bad, it actually could fit a line to it if we'd like it to. It could really, if we really wanted to, it could fit a sinusoidal curve to it. Might not be a great fit, but it will do it. And sometimes I let students do that because I think it's interesting for them to see what happens if you put a line to it. What's that line going to look like? Sometimes they think it's quadratic, and so they put a quadratic to it.
That reminds me of one of my favorite quotes, that all models are wrong, but some are useful.
Yes.
All right, so in closing for tonight, we promised that one lucky winner is going to be receiving a TA graphing calculator of their choice. So tonight's lucky winner is George Picaro. So George, congratulations. We'll be reaching out over the next few days here over email to get some information from you, but start thinking about which calculator you'd like to receive. To download a certificate of attendance, go ahead and click the link in the chat window. Also list as links for the documents. And if these links aren't working or if you miss them for some reason, just hang tight. You'll automatically get a follow-up email with links to the recording, the documents, and the certificate as well. And if you're watching this on demand, go and copy that link into your browser. And it's possible that maybe you asked some questions tonight and maybe we missed them. Feel free to reach out to us, 1-800-TI-CARES, or drop us an email, ti-cares@ti.com. We'd love to hear from you. And we did try really hard to make sure we got all your questions answered. But if a couple slipped through the cracks, again, we apologize. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback really guides us as we plan future online webinars, just like this stats webinar. So please let us know what you liked, what you think we could have done better, and if there's anything you'd like to see in the future, we'd love to hear your thoughts. Huge thanks to Diane and Carl Hines. Thanks so much to both of you. Carl, I'm glad that you're able to get on, and Diane, thanks so much for picking up the couple extra pieces there at the beginning. And you guys make a great team. Thanks so much.
Thank you. Thank you, everybody.
Good night.
Good night.
Thanks so much, everyone, for joining us. We hope to see you back online next week. Have a great night.